Trigonometric graph transformations. In Core 1 we first came across graph transformations. Now what we're going to do now is we're going to try and use those graph transformations that we learned and apply them to trigonometric graphs. So the first one we're going to look at is sketch the following graph. So we're going to sketch y equals 3 cos theta between 0, theta and 360 degrees. So first thing we need to do is we need to set up our axes. Now to help with these questions it's probably worth also sketching down what the normal cos theta graph looks like. So cos theta graph between 0 and 360 usually starts from 1, goes down to -1, cuts through at 90, down to 180 at -1, up to 0 again at 270, and then 1 again at 360 degrees. Well, what we're doing here in our sketch graph is we're asked to do 3 cos theta. So we're taking our cos theta graph and we're multiplying each value by 3. So cos 0 is 1 and 1 times 3 is 3. So our new maximum is going to be 3. Likewise, cos of 180 was -1, so 3 lots of that is -3. Cos of 90 gave us 0, well 3 times 0 is still 0, so it's still going to cut through at 90, 180, 270, it's still going to be 0, and 360 is going to be, cos of 360 is 1, 3 lots of that is 3. So it's going to still follow the same curve, but this time it's going to have maximum and minimum limits of 3 and -3. This time for us to do y equals minus sine theta between -180 and 180 degrees. So yet again, good idea to sketch the graph that you're looking at. So y, and here's your x or theta. So it's going to be between -180, -90, 0, 90 and 180. So your normal sine curve goes between 1 and -1. And we know that sine of 0 is 0, sine of 90 is 1, sine of 180 is 0 again, and that means that sine of -90 is -1, and sine of -180 is 0. So this is the curve of y equals sine theta. But we're asked to do y equals minus sine theta. So all our values are going to be multiplied by -1. So sine of 90 is 1. Well, if we multiply that by -1, it will be -1. So basically, it's our original graph reflected in the x-axis, or the axis where theta is in this case. So our sketch would be like this, between 1 and -1. Of course, what I've done there is I've not accounted for the fact that we're going from -180 to 180. So it's going to go between 1 and -1, -180, -90, 0, 90 and 180. And there's my thetas. So remember, it's our original graph reflected in the theta axis. So this time it's going to go like this. Of course it should just cross there. Right, next thing we're going to look at is we're going to look at y equals 2 plus cos theta between 0 theta and 2 pi. So quickly sketch what cos theta looks like. Well, we've done that already once. So 0, pi over 2, pi, 3 pi over 2 and 2 pi, because remember we're working in radians on this question, so our axes must be in radians. So it starts at 1, goes down to 2, through 0 at pi over 2, down to -1 at pi, up to 0 at 3 pi over 2, and then back up to 1 at 2 pi. So this we're adding on 2, so we're taking a cos theta value and adding on 2 to it. So cos of 0 is 1, if we add 2 to 1 we end up with 3. Likewise, if we look at cos of pi, which is minus 1, we're going to add 2 to that, well minus 1 add 2 is going to be 1. So our maximum and minimum limits now are going to be 3 and 1. So our axes sketched. So we're going between 0, pi over 2, pi, 3 pi over 2 and 2 pi. So remember, cos of 0 is 1, add on 2 is 3, and pi, cos of pi is minus 1, add on 2 is 1. So there's our two limits, and what used to be 0, so cos of pi over 2 is 0, and 0 add on 2 is 2, so what was our 0 line originally is going to be 2 now, and it's going to go, so it's going to go through this point here, that point there, that point there. It's going to look like that. Next graph. Y equals sine theta minus pi over 6 between minus pi theta and 2 pi. Now let's look at two slightly more difficult examples, which is this one, sine theta minus pi over 6 between minus pi theta and 2 pi. So let's firstly sketch our graph again for what sine theta usually looks like, which we should be getting quite used to now. So minus pi over 2, 0, pi over 2, pi, 3 pi over 2 and 2 pi. And we know it starts at 0, goes up to 1, down to 0, down to minus 1 there, and it will continue this way, up between 1 and minus 1. Now, when we're doing pi minus 6, well, this means that the graph is going to shift to the right by pi minus 6, because if we looked at pi over 2, for example, so if we sub pi over 2 into our equation, well, it'll be pi over 2 minus 6 pi, which is 3 pi over 6 minus pi over 6, which is 2 pi over 6, or a third. So whatever sine of a third is will be what happens when you put pi over 2 in, which sine of pi over 3, or sine of 60 degrees, is, which is root 3 over 2. So sine of pi over 3 is root 3 over 2. Now, when we come to sketch this, we need to bear this in mind. So let's draw our axes. So here we go, y and theta, y and theta. Okay, let's put in our values, of course, for theta. So pi minus pi over 2, 0, pi over 2, pi, 3 pi over 2 and 2 pi. It's still going to go between 1 and minus 1. So remember, we've just found out that when pi over 2 is put in, we end up with root 3 over 2, so we're not quite at 1. Well, the value that would in actual fact give us 1 is 2/3 pi, which is just above there. Okay, so that's the first bit. So everything's shifted by pi over 6 to the right from its original place. So instead of pi, it's going to be 6 pi. So it's all shifted slightly to the right. Instead of 0, it would be pi over 6. So it's just all shifted slightly to the right hand side. So that's the first section, and you should hopefully be able to continue on the pattern. And it's not going to hit 0 when it gets 2 pi, it's still going to be below it. Likewise on the other side, minus 1 is now not going to be at pi over 2, it's going to be at minus pi over 3, and it's going to cut through 0, not at minus pi, it's going to cut through it just before minus pi and continue up a little bit. So that's a difficult one, so you might want to just try a few values into the equation before trying to sketch it. And finally, y equals 2 cos in brackets theta plus 45 degrees between 0 and 360. So if we just sketch the cosine graph between 0 and 360, we know by now that it takes the following shape, hopefully. Right, and we're shifting this 45 degrees this time to the left, and then we're going to double each value. You might want to do this in 2 stages. So the first stage might be to shift it to 45 degrees to the left. So 0, 90, 180, 270 and 360. So let's firstly shift it 45 degrees. So now instead of crossing 0 at 90, it's going to cross at 45. It's not now going to cross 0 at 1, it'll be below it at the value 1 over root 2, which we can find from our using our calculator and typing in cos of 45, or doing cos theta, cos of 0 plus 45 will give us root 1 over 2. So it's all shifted 45 degrees to the left. Of course it'll start to dip back down again because it will get to 1. So now that's the first bit, that's the theta plus 45, but we need to double each of these answers. So instead of crossing at 1, it's going to cross at 2 and minus 2. So we extend our axes, and it's going to cross, so everything's going to happen. So 1 will now become 2, so it's going to become twice as big. Now 1 divided by root 2 doubled is the following. So 1 over root 2 times 2 is equal to 2 over root 2, which is 1.41 using a calculator, so it's going to hit above 1. So here, it's still going to cross at 0 here, and I'm going to go twice as big here, still cross here, twice as high there. So there's the graph in blue of y equals 2 cos in brackets theta plus 45. Now it's really important, folks, you are fully happy with all the different graph transformations that you can do on trigonometric graphs, and my personal advice is to sketch the original graph before trying to carry out the graph transformations.